Hi friends, I Robin. Welcome to our YouTube channel Star Science Robinson. Congestive cardiac failure. So today we're going to see about congestive cardiac failure. So first we have to see the definition. Congestive cardiac failure is decreased cardiac output to meet the metabolic demands of the body. So where in this condition which the heart loses the ability to pump blood efficiently throughout the body, so it can't meet the demands of the body. So first we'll see about two things. So first we'll see about systolic heart failure, and we'll see about the diastolic heart failure. So before going for that, we'll see about the systolic heart failure. So the systolic heart failure can't pump blood enough. Diastolic heart failure. So in diastolic heart failure, it can't fill enough of blood. So this is the two things which we have to remember about. So because of these things, there will be blood in lungs. So congestion, fluid buildup in a lung. So this is the things we have to remember about in this particular phase. So now we will see about the cardiac output. What is cardiac output? The cardiac output is volume of blood per minute. Stroke volume. So stroke volume is equal to end diastolic volume minus end systolic volume. So that is stroke volume. Now we'll see about stroke volume and cardiac output. So that is beat per minute into volume of blood per beat. So that is, for example, if it is around 70 beat per minute into 70 ml per beat, so is equal to, there will be around 4900 ml per minute. So it's approximately 4.5 or 4.9 liters to 5 liters per minute. So that is the thing which is happening here. That is cardiac output and stroke volume. So this is the thing you have to remember about. And next we'll move on to two sides. I'm just going with systolic heart failure, and other side I'm going to see about diastolic heart failure. So first we'll see about the systolic heart failure. So I'll go with the diagram and I'll explain. So in this diagram I want to show exactly what will happen in this phase. So if you see about the stroke volume, which is in aorta, so the blood which has been ejected through aorta through all the parts, so it is around 70 ml. So that is the thing you have to remember here. So next we'll see about the total volume. So what is meaning of total volume? The total volume is nothing but the blood which is being received by the ventricles. So it will be almost 90 ml plus or minus 15. So it will be almost 110 ml capacity. So that is total volume. So if you see about end systolic volume, so what is end systolic volume? The end systolic volume is around 40 ml. So if you minus 70 from 110 of total volume, it will be around 40 ml. That is called, after contraction phase there will be 40 ml which is being remained in our heart. So that is the thing I'm showing you right now here. So we'll see how much the blood will be ejected in total volume 110 ml. In that, if around 70 ml has been ejected, then the 40 ml will be remaining. So end systolic volume. So I'm showing you right now 70 ml by 110 ml. So if you see in this way, it will be around 64 percentage which has been ejected. So now we can remember, when there is no proper functioning, that is pumping of blood from the heart, so that is called as a systolic heart failure. If it is around 70 percentage or 50 to 70 percentage, it is normal. So if it is less than that, either it is like 40 to 50 percentage of ejection, then it is considered to be as a borderline effect. Or if it is less than 40 percentage, then it is severe, so there is no proper ejection or pumping of blood, so it is called as systolic heart failure. So this is about the systolic heart failure. So there will be no proper functioning of pumping of blood by our heart. So next we'll see about the diastolic heart failure. So now if you see about the diastolic heart failure, now again we'll see about the total volume. So where in this phase, diastole heart failure, where it can't fill enough, so here total volume will be very much reduced. So when there is no proper enough of blood which is been filled, so the problem is considered as diastolic heart failure. So for example, if you see about the ejection phase, here how much blood will be ejected. So if you see in this diastolic heart failure, the ejection phase, for example, if there is the place in our ventricles is very less, because the thickening of heart layer myocardium. So now if you see about, there will be around, the total volume will be around 69 ml. So because there is no proper space, it is around 69 ml, and the ejection phase where it is been sending 44 ml in aorta. So there will be a ejection percentage, if you see in detail, it will be around 64 percentage. But even though it is 64 percentage, total volume will be very less, so there will be filling of blood in our ventricles will be less, so ejection also will be less. But because we have less total volume, so we'll have a 64 percentage, but it is not enough, so it is also diastolic heart failure. So here we can remember as abnormal filling, so reduced preload blood in our ventricles before contraction. So this is about the diastolic heart failure, because there will be no space for filling enough of blood in ventricles. Now you can remember, so systolic heart failure, where it doesn't pump enough of blood. So in diastolic heart failure, it doesn't have enough space to get filled of blood to get ejected into aorta. So this is the phases where you have a congestive cardiac failure. So just remember, we am going to see in detail of our both the things, that is, so systolic heart failure, at the same time diastolic heart failure. Now let's see about the systolic heart failure. So in systolic heart failure, I'll just explain in 3 steps, I mean in 3 diagrammatic, where you can just remember. So I'm telling you about the left side of our heart. So we are going to see in left side and sides of our heart, where it is not unable to pump enough of blood. So here if we go with the first diagram, so I'm going with the first diagram of left side of our systolic heart failure. So here you just remember, I'm going with the different parts of our heart. You just remember, I'm just concentrating on the left side. You see, when you have an aorta and pulmonary artery, I'm just seeing about the layer of our heart. I mean, I just want to see the muscle of our heart, how much thick, and in diagram you just see that. So that is the variation you have to remember about. So now I am going with this diagram. So septal ventricular septum I am drawing with, and if you see about the apex and the left ventricle where the valve, so it is been thickened, and there will be a scar tissue. So I'll teach you later about that. So where here the problem is unable to pump proper enough of blood, so where it unable to meet the demands of the body. So that is the thing you have to remember about. And now we are going with the first phase, so that is ischemic heart disease. So ischemic heart disease, here if you see, it is coronary atherosclerosis. So coronary atherosclerosis, also called as atherosclerosis cardiovascular disease, and that the build up of fat, cholesterol and other substance in on the artery walls, causing the arteries getting obstruction of blood flow, so where you will not have proper blood supply to the myocardium, so there will be scarring tissue of myocardium. So next, if you see about this, there will be damaging of this myocardium. So because there is no proper blood supply to the heart layers, so the pumping work will be done by the myocardium, so there will be reduced work by the myocardium. So I'm just drawing you a coronary artery, so that is called as a plaque. So plaque is nothing but the cholesterol and fats which is been deposited in the walls of our coronary artery valve, so where it will be a blockage, so there will be no proper blood supply to the myocardium. So at that phase it will be obstructed, so it will be scar of tissues, so where it will be damaged of myocardium, so which will lead to weakening of myocardium, where pumping of heart will be reduced. So it is also one type of systolic heart failure. And second, we'll see about the systolic heart failure. So I will go with the diagram. So here you just remember about this diagram also. So we are going with a diagram of heart and chambers. I'm just concentrating on a left ventricles, so you just remember about. So here also if you see, there will be thickening or enlarged layer of our heart in left ventricles, just to show you what will happen. So here the second phase, it is called as a hypertension. So because of hypertension, atrial pressure will increase. So when there is atrial pressure increases, there will be harder to pump the blood from left ventricle, because there will be a hypertrophy of the left ventricle, the valves of our heart. So next, because of that, there will be increased O2 demands, and it will try to quizzes coronary, and when they go for quizzing of coronary, because there will be obstruction in coronary because of plaques and cholesterol fats, there will be weaker contractions of coronaries. So this is about the second in systolic heart failure. So when they have a hypertension, because of that there will be atrial pressure will be increased, and due to hypertension the atrial pressure increases. When atrial pressure increases, it is very hard to pump by the left ventricles. So the pressure in atrial is higher, then it is very hard from the left ventricle to pump blood, so it is harder to pump by the left ventricles. So due to that, it is hypertrophied. I mean, the left ventricle is now hypertrophied. So when it is hypertrophied, and now the oxygen demands is higher, but now it is trying to cuse the coronary, but it is unfortunately not having a proper supply, so it is weaker in contraction. So this phase will lead to systolic heart failure. Next we'll go with third one. So we'll go with the diagram, so I will explain and what will happen here. So now we have to see in third one, it is dilated cardiomyopathy. So first of all, we have to know what is dilated cardiomyopathy. So dilated cardiomyopathy is the heart muscles becomes weakened, and after weakening it will become enlarged. So as a result, the heart cannot pump enough blood to the rest of the body. So this is the main thing which we have to remember about. So dilated cardiomyopathy, so where the heart muscles will become weakened. So because it is weakened, so it will get enlarged, so it is unable to pump blood to rest of the body. So right now we are seeing about this diagram. So we'll see clearly here what will happen in this ventricle. So now you have to see in both the phases we have seen about the left ventricle. So here also we want to see about the left ventricles. So we are talking about the dilated cardiomyopathy. As we know, it is weakening of the heart muscles. So now when it is weakened, the wall of the left ventricles will be thin and weak. So here this is the variation you have to remember about. So in upper two, where we have seen about the steps, we have seen about the enlargement of the left ventricles, but we are seeing here it is enlarged, but it is very thin and weak, and it is been very stretched. So that is the thing which we are going to see in this step. So that is dilated cardiomyopathy. So we are going to see right now. So we are going to see about this. There will be a chamber grows because there will be a filling of blood higher or increased or more filling of blood. Because filling of blood, the chamber will grow, so the contractions will increase. When the contraction increases, or it will stretched, so when it is stretched, the thin and weak. So when we have a thin and weak of the wall of our myocardium, so where there will be no proper functioning of our heart muscles to pump the blood. So because the myocardium work is to pump the blood, so now because it is thin and weak, it is very hard to pump the blood. So that is the thing which we see here. So just remember, when the chamber grows and filling increases, so contraction stretches thin and weak of the ventricles. So systolic heart failure. Now we are going to see about the diastolic heart failure, left side. So we are going to see about the diastolic heart failure. So first we have seen about diastolic heart failure means can't fill enough. So because there is a enlarged ventricles, the space inside the left ventricles will be very less, so there will be shortage in filling of blood. So that is the thing we are going to see in this diastolic heart failure. Now I am going with a diagram to show you the ventricles where there is less place so to get filled. So because of there is less place to get filled of blood, so the less blood will be sent. So because of this we will have a diastolic heart failure. So now I am showing in diagram, there will be very much less place in left ventricles. So there is not enough of blood to be get filled in our left ventricles. So first we'll see about this. I will tell you in 4 steps. First we'll see in first step, that is hypertension. Because when there is an hypertension, so when there is an hypertension, the atrial pressure will be higher, so where the hypertrophy of the left ventricles. So when there is hypertrophy or stiffening of the left ventricles, so there is a less place for filling of blood in our ventricles. So this is the first phase where we can see about the diastolic heart failure. So next, if you see in this, when it is hypertrophy stiff, there is no place to get filled by the blood. So now we'll see the next phase, that is because of this hypertrophic cardiomyopathy. I mean, when there is an hypertrophic stiffness of ventricles, there will be a weakening of the muscles of the heart. So when there is weakening of the muscles of heart, then there will be aortic stenosis, which is narrowing of a aorta. So when there is a narrowing of aorta, then the blood will not flow properly into the aorta, which will also result in diastolic heart failure. This we can say that when there is narrowing of aorta or stenosis of the aorta, so there will be the blood will not pass properly into the aorta to meet the demands of our body. So it will indicate that it is also called as a diastolic heart failure, because when it is not sure to get for the systemic circulation, then we can say that it is also diastolic heart failure. So this is the thing which you have to remember about. So we'll move on to the next phase of our lesson. So that is about the third phase of our lesson that we have to remember. So restrictive cardiomyopathy. So first we'll see what is restrictive cardiomyopathy. So the restrictive cardiomyopathy is when the wall of the lower chamber of heart, so ventricles, it is too rigid to expand as they fill with the blood, and the pumping ability of the ventricles may be normal, but it's harder for the ventricles to get enough blood. With time, the heart can pump properly. So it means obstructive cardiomyopathy. So that is weakening of the heart muscles. So it will become a stiffer of the ventricles. So when there is stiffer of the ventricles, it can't stretch to get filled by the blood. So when there is no space to get filled by the blood, so then there will be no proper blood will be sent to meet all the demands of our body by the aorta. So it will also will result in diastolic heart failure. Once again we'll see. So restrictive cardiomyopathy. So restrictive cardiomyopathy due to weakening of the heart muscles, especially in lower phase of our heart, that is ventricles. So when it becomes stiffer, there will be less filled blood because they can't stretch properly. When there is a stiffness in ventricles, they can't stretch properly, so the blood will not get filled enough. So it will lead to diastolic heart failure. So next we'll see about the fourth part of our lesson. So when we see about this step, I just go with a diagram. You just remember, when I'm going with this diagram, the less blood to kidney, which will increase renin, angiotensin, aldosterone. So when it occurs, the fluid retention occurs. Fluid retention, filling and preload increases. So when there is filling and preload increases, then the contraction and or stretches will increase, because filling and preloaded will increase and it will go for a stretching increases. So due to this, there will be again the fluid retention occurs. So when there is fluid retention, then there will be leaks from the blood vessels. This is the major point which we have to remember about. So when there is a leaks from the blood vessels and fluid, so fluid buildup occurs in lungs and other parts of our body, so which will resulting in a, because of fluid buildup, the blood from the heart again it enters into the pulmonary veins. After reaching from the pulmonary veins, it enters into the lungs. So the fluids now enters into the lung, and from lung it will enter into a pulmonary artery. Due to that, there will be higher pressure in pulmonary artery. So the fluids which will be filled in the interstitial space, where there will be a pulmonary edema. So due to this, there will be no proper exchange of gases in our lungs. So now I'm showing you when it is reversing back from the left atrium to the pulmonary veins to the lungs, and from lungs to the pulmonary artery. That is the pressure which has been created into pulmonary artery, so which will lead to a fluid buildup in the interstitial spaces, so where it is called as a pulmonary edema. So these are things we have to remember mostly. So I'll show you when this occurs in this phase, what will happen in alveoli. So I'll show you in a diagram what will happen because of this in our lungs. So there will be fluid filled in our lungs, so there will be no proper exchange of gases done in our lungs, so there will be no proper oxygenated blood to our parts of our body. So this is the main thing we have to remember about. So when there is congestive cardiac failure, so this is the things process which has been occurring, so you have to remember about. So we'll go with a diagram. First we'll see about the lungs, how it will appear after this phase occurs. So we'll draw a lung right now. So after drawing a lung, we'll go in deeper of our lung where bronchioles, or it will be converted into a alveoli, so where the gases exchange occurs in our lung. So we'll just go through it. Now I want to show you this mechanism which has been happened reverse back, that is fluid filled in our lungs from the left atrium to the lungs through pulmonary vein, and from there lungs to the pulmonary artery, the pressure buildup. So interstitial space where the fluid buildup, it is called pulmonary edema. So now I am going with an artery, or you have to remember about the pulmonary artery. So where you will be having right now, drawing about the bronchi and bronchioles and all that, and I am just drawing about the rounds, which is nothing but it is alveolus. So I'm just going with that, and I'm just explaining about alveoli. So this is the sac and where the exchange of gases occurs in our lung. So from pulmonary artery, so there will be CO2 blood. So now the CO2 should be entered into the alveolus, and it is receive the O2 from the alveoli. But now here what happens is, when there is a fluid filled in our lungs right now in alveolus, there the macrophages in alveolar macrophages will just eat up the RBCs from the pulmonary artery. It is called as hemosiderin and leadin, so which is called as a heart failure cells. So that is the thing which I am going right now. So it is also indication that the heart failure. So just remember, when there is alveolar macrophages, when it eats up RBCs in our pulmonary artery, then it is called as hemosiderin leadin, and it is also called as a heart failure cells. Thank you friends for watching. It's Star Science Robinson. Thank you. Once again, thank you.